Assalamu alaikum and good morning. So today we are going to go through exercise 10.1 based on the votes that you have submitted on forms. So the first question that I want to look at is question number 4. The group 1 metals have lower melting points than the group 2 metals. What factors result in group 2 metals having higher melting points? So when we talk about melting points, we have to know which bond we are breaking, and because group 2 metals are giant metallic structure, so the bond that we're breaking is the metallic bond. That means if we want to compare about the size of the melting point, we have to look at the strength of the metallic bonds. In topic 4, you have learned that strength of metallic bonds depend on the size of the ion, the positive cations, as well as the number of electrons that are being delocalized into the sea of electrons. Okay, so the first option where it says group 2 metals have higher first ionization energy than group 1, this is wrong because group 2 actually have lower first ionization energy than group 1 metals. Okay, so if you look this up, then this first statement should be wrong. There are smaller interatomic distances in the metallic lattices of the group 2 metal. So as I mentioned just now, the first factor is the size. And it's true that the group 2 metals in terms of size are smaller than their neighboring group 1 metals. Okay, so this is topic 9, where we learned that as you go across the period, you would expect the size to increase, but actually it decreases. Okay, and the third statement is more electrons are available from each group 2 metal atom for bonding the atom into the metallic lattice. Okay, so that is not an obvious statement to say that there are more electrons to be delocalized. Okay, but that's what statement number 3 is saying, that there are more electrons that will be released into the sea of electrons. So the only options that are correct are 2 and 3. So that's why the answer is C. Next question, we will look at question 8. Which statements about calcium oxide are correct? It is produced when calcium nitrate is heated. Okay, so if you look at the decomposition of calcium nitrate, it will give out calcium oxide plus oxygen plus nitrogen dioxide gas. Okay, so that's not a balanced equation. It can be reduced by heating with magnesium. Nope. Also, we did not cover or learn that reaction in our syllabus. It reacts with cold water. Yes, calcium oxide reacts with cold water because as you go down the group, it gets more, the oxides gets more soluble. Okay, so that means only statement 1 and 3 are correct. That leaves out with statement 2, which is not mentioned in the syllabus, so we would just assume that this reaction doesn't happen. Next question is question number 10. Which solid products are produced when the firework is lit? So you've got magnesium in the firework. You've also got the barium nitrate in the firework. And what happens if you burn them? So when you burn them in the presence of oxygen, you would expect magnesium oxide to be formed. Barium nitrate, we don't know if it reacts with oxygen, but we know that in the presence of heat, in the case of firework, you would need to burn them in order to see reactions being produced. That means this heat can also be used by the barium nitrate for it to decompose. Okay, so as you all know, when barium nitrate decompose, it will be decomposed into barium oxide plus oxygen and nitrogen dioxide. Again, that is not balanced, so please be careful. So this is decomposition. and this is combustion. Okay, magnesium nitrate, well, you don't have a source of nitrogen or nitrogen oxides to form the magnesium nitrate. Okay, so we will settle with option 1 and 2 only. Next question would be question 13. Okay, so when it comes to this kind of question, and I can tell you that Cambridge loves to ask this question, they use unknown compounds or unknown formulas using letters. Okay, so what I like to do, even for me, I have to write it down. I cannot just visualize everything in my head. So thermal decomposition of compound S releases carbon dioxide gas and forms a white solid. The fact that carbon dioxide gas is produced is a big hint that tells you S is made up of your group 2 carbonates. Okay, and it forms a white solid. When group 2 carbonates decompose, it forms an oxide. So I would just call it a metal oxide plus carbon dioxide. Okay, so that means the most important thing, the most important information that I can get from here is that S must be a group 2 carbonate. Okay. S and T are not soluble in water. So that means you have to find, so S is again, as I said just now, magnesium carbonate. All carbonates of group 2 are insoluble. So that's not helpful. However, the metal oxide, we know that for your oxides, as you go down the group, it gets more soluble. Okay, so the insoluble metal oxides are the ones at the top. So I usually refer to the top group. So it's either magnesium or calcium. Okay, so calcium, you already start to see that it is partially soluble. Okay, this was mentioned a few times in the topic. So our best guess would be magnesium carbonate. Okay, because if we compare magnesium carbonate and calcium, oh, sorry. I'm confused with sulfate. The top oxides are insoluble. The bottom oxides are soluble because the solubility of your oxide as well as your hydroxide increases as you go down the group. So between calcium and magnesium is insoluble. Okay, calcium would start to dissolve a bit, and then strontium, barium would be like really soluble. Okay, so we choose the higher they are in the group. So in this case, that's why I have chosen magnesium and not calcium. Now calcium is a possible option, but if you are given two choices between magnesium and calcium, magnesium oxide is less soluble than calcium oxide. Okay. Next question is question 14, a mixture of two group 2 elements. Okay, why? Were thermally decomposed. This reaction produced white solid and two gaseous products. Okay, when we talk about decomposition, there are only two types: carbon dioxide, the decomposition of your metal carbonates, okay, or the decomposition of your metal nitrates, right? In which case, both of them will produce metal oxides, but with carbonate, the gas that you would form would be CO2. With nitrates, the gas that you would form would be oxygen and nitrogen dioxide. So the question already mentioned that two gaseous products are being produced. That means it has to be a nitrate. Okay, which one of the gaseous products relights a glowing splint. So that is again another hint that oxygen relights a glowing splint. So if you think about it, that means that in Y, there must be two nitrates. Okay, there cannot be any carbonates. So nope, option A is not accepted because there's carbonate. The reason why there cannot be a carbonate is because if there was a carbonate, you would have detected carbon dioxide. Okay, so the only possible option is option D, where two nitrates are combined or are mixed in Y. Because it produces two products and the two gaseous products, and the two gases are oxygen and nitrogen dioxide. Okay. Next, when equal volumes of saturated solutions of barium hydroxide and calcium hydroxide are mixed, a white precipitate Y is formed. So what happens? As for your hydroxide, the top part, the higher or the top hydroxides are less soluble. Okay, so if you compare between barium hydroxide and calcium hydroxide sits above barium hydroxide. So calcium hydroxide would be partially soluble, okay, whereas barium hydroxide would be very soluble. That's why I should actually write this as there's nothing wrong with my barium hydroxide because we know that it is soluble. However, for your calcium oxide, calcium hydroxide is a little bit on the fence. Okay, it is partially soluble, so sometimes you will see it as being written as solid. Sometimes you will see it being written as aqueous, but you need to bear in mind that they are insoluble. Okay, so what happens when you mix both barium hydroxide and calcium hydroxide? What you are doing is actually there is no reaction here. Okay, you are just adding more water to the calcium hydroxide. So now, okay, the sorry, there's essentially nothing happening, okay, but because of something that you have not learned, which is called the common ion effect. So because you are adding more hydroxides into the mixture, okay, the calcium hydroxide, which was partially soluble, now becomes fully insoluble, okay, because you now have a lot more hydroxide, so more precipitate is formed. Okay, so that means a white precipitate, that white precipitate of Y is actually still your calcium hydroxide, but it's now more apparent or more obvious. Okay, the mixture is then filtered, so that means you've got your barium hydroxide in the water that you collect, or the solution that you collect. Okay, so if you, since calcium hydroxide is in the form of the solid, if you filter it out, then you manage to separate your calcium hydroxide, and then your filtrate, I think it's mentioned here, okay, bubble through the filtrate. So what happens is that the solution that you collected is actually just your barium hydroxide, okay? And then if you bubble some carbon dioxide into your barium hydroxide, okay, so you start forming a carbonate ion, so you will produce barium carbonate, and barium carbonate is insoluble because all group 2 metals are all group 2 carbonates are insoluble. Okay, so that's why your second white precipitate Z is barium carbonate. So the answer is C, because Y is your calcium hydroxide here, and then at the end is your barium carbonate Z. So you really have to draw out the flow in a way, okay? So you can see what's happening. Next question is question 16. A colorless solution was formed when metal Y was reacted with water. This solution then gave a white precipitate when mixed with aqueous sulfuric acid. Okay, so when Y dissolve in water, you form a colorless solution. So that means your hydroxide is soluble. So when it comes to hydroxide, solubility increases down the group. So you would expect this to be either barium or strontium. Okay, so even without moving on to the next piece of information, as I said, as I mentioned just now, only barium and or strontium is possible here, and you have a barium in the option. Okay, however, if you need further explanation. When barium hydroxide react with sulfuric acid, you will form a barium sulfate ion. And that barium sulfate is the one that gives you a white precipitate here. Okay, so that means metal Y is barium. Let me just write this down. It's aqueous, a colorless solution. So that colorless solution is actually your barium hydroxide. Okay, next question is question 17. So that will be the last. A student performs several experiments on element Y and alkaline earth metal. So that tells you that element Y comes from group 2. When added to water, Y hydroxide. So Y hydroxide means this, okay, where Y is a metal ion. Y hydroxide dissolves in water. Okay, so that means it is a soluble hydroxide. Soluble hydroxide would be at the bottom, either barium or strontium. Again, similar to the previous question. Y sulfate produces a white precipitate. Okay, in terms of group 2 sulfates, the solubility decreases as you go down the group. So you would expect to see a white precipitate. So these two pieces of information, point number 1 and point number 2, tells you that the metal belongs to the bottom metal, okay, either barium or strontium. In order to thermally decompose Y nitrate of more heat, okay, in order to thermally decompose Y nitrate off, more heat is required than to thermally decompose strontium nitrate. So we have to talk about thermal decomposition. And as we know, decomposition cannot spell. As you know, for the group 2 nitrate, okay, the bottom nitrate is more stable. That means need more heat, whereas the top nitrates would be less stable, less energy or less heat is needed to decompose or to break down the nitrates. Okay, so here it is saying that Y nitrate, more heat is required for Y nitrate compared to strontium nitrate. So that means Y has to sit below strontium. Okay, so it is saying that Y nitrate is here. And then strontium nitrate is here. Even if you stop at this point, you should already know who sits below strontium nitrate, okay? This information comes from point number 3, and that is crucial. If you cannot understand that statement, then it's difficult for you to figure out this question. When burned in oxygen, Y will readily become YO. Okay, we know that because as you go down the group, the group 2 elements are getting more reactive. Okay, so option number 4 doesn't really help us much doesn't help us much with identifying the element, but point number 3 is the most important. Okay, the fact that you need more heat or more energy to decompose this Y metal nitrate tells you that the nitrate is more stable than the strontium nitrate. Okay, so it must sit below strontium nitrate. And the only person that we know in our syllabus that sits below strontium nitrate is barium. Okay, and all the other options that are given to you are for elements that sit above the strontium nitrate. So you can sort of figure this out already the moment you look at point number 3, and you have to understand that point. Okay. Right, so that is all for today. I hope I answered all, if not most, of the questions that you needed help with for exercise 10.1. Okay, Assalamu alaikum, and thank you everyone.